Hello everybody. In this video I'm going to take a look at question 27 from chapter 7. It says write the Lewis structure for the diatomic molecule of P2, diatomic phosphorus, an unstable form of phosphorus found in high temperature phosphorus vapor. So the first thing I always do is I write down which type of atoms I have. So I only have one type in this problem. It's a phosphorus. The next thing I'm going to do is write the abbreviated electron configuration. In order to do that, I'm going to come down to our table for the electron configurations. And I'm going to take a look at phosphorus here. So 3s2, 3p3, and the core is going to be neon. So I come up here, and I say that this guy is neon 3s2, 3p3. So phosphorus is a main group element. So to find the valence electrons, I look at the ones that have the highest n value. These are both 3, so they both count. And I'm going to sum together these superscripts to come to the conclusion that there is 5 valence electrons for phosphorus. That's always going to be true for phosphorus, so that's just a fact that we know now. The next thing I need to do is figure out the total number of valence electrons I have. So I only have phosphorus, but I have 2 of those. So I'm going to have 2 phosphoruses times the 5 valence electrons for each one. It's going to give me 10 valence electrons. I like to think of this kind of like my bank. So these are all the electrons that I need to dole out while I'm writing this Lewis dot structure. Now that we know that, the first step is going to be to write the skeletal structure. We only have 2 atoms. They're both phosphorus. They must be attached to each other. So the simplest form I could imagine is one phosphorus atom attached to the other phosphorus atom. Now in doing that, I created a bond. That bond contains 2 electrons, so that's 2 electrons out of my bank. So I started with 10 electrons in my bank right here. I created one bond. That one bond contained 2 electrons. I have 8 electrons left over. Those 8 electrons need to get dispersed onto these 2 phosphoruses as lone pairs. So I will just do that right now. We're going to have one phosphorus attached to the other phosphorus. I need to add 1, 2, 3, 4, 5, 6, 7, and 8. And that is my whole bank at that point. I had 8 electrons left in the bank. I just exhausted 8 electrons drawing dots. I have 0 electrons left over at that point. Now what we need to do is consider the octet for each one of these atoms. And in order to do that, we need to do a count. And the way that that count is going to go is each one of the dots is going to count for 1, and the bond is going to count for 2. The other caveat here is that this phosphorus here and this phosphorus here both get to count this bond. They're sharing those electrons. So that's going to the electrons in this bond are going to get double counted for the different they're going to get double counted for this atom and for that atom. So let's do our count here. We got 1, 2, 3, 4, 5, 6, so that's 2 short of an octet for this guy. And this one is the exact same way. So 1, 2, 3, 4, 5, 6. He's also 2 short of an octet. So in order to get that to happen, what we're going to need to do is to get them to share more of the bonds between them, more of their electrons between the two. And that's going to happen by increasing this bond order here. So instead of a single bond, we need to make this a double bond. And there's a couple of different ways that you could kind of think about doing this, but what I'm going to do is I'm going to imagine that this lone pair here comes down to form the second bond here. I'm going to rewrite that now. So I have P with the 2 lone pairs. I just rewrote that. I'm now going to have a double bond there. This guy's now only has this 1 lone pair left over. Let's do our count again. Now from this guy's perspective, he has 1, 2, 3, 4, 5, 6. Still 2 short. From this guy's perspective, he has 1, 2, 3, 4, 5, 6, 7, 8. He's now happy. Okay? Now, this is where it can get a little counterintuitive. I see people get a little confused at this point because this guy's happy, so it seems like maybe I need to do something with this one. But that's not the way to think about it. The way to think about it is that this guy still needs 2 electrons. Okay? They have to come from this guy. He has to start sharing his electrons with him. So just like how moving this lone pair down caused this guy to have his full octet, the other one, let's see what happens when we move this lone pair down. Okay, now let's look at the count that we have now. So from this phosphorus perspective, he has 1, 2, I'll make that dot kind of big, 3, 4, 5, 6, 7, 8. From this guy's perspective, he has 1, 2, 3, 4, 5, 6, 7, 8. And they both have their full octet, so this is going to be our Lewis dot structure for this diphosphorus compound.